Everyone, this video continues the introduction to derivatives, focusing on the interpretation of the derivative as one of the inputs to define the equation of a tangent line. A tangent line defines a line that best approximates a function at a given point. To calculate the tangent line at x equals a for a function f of x, we have to calculate all components that get plugged into a line. The minimum requirements to define a line include one point on the line, so that would be an x, y coordinate, say x1, y1, or a, b, if you want to use those letters. And the other input is the slope of the tangent line. We saw earlier that the slope of a tangent line, interpreted as an instantaneous rate of change, is something we get from the derivative. So, our problem-solving process to create a tangent line for a function is going to be, first, we have to be usually told what the x-coordinate is. We'll plug that x-coordinate back into the original function to get the corresponding y-coordinate. That will then give us an xy pair, a point on the curve. And that point on the curve will be also a point on the tangent line. The next thing we have to do is we have to find m, the slope. So what we'll do is we'll take the derivative of the target function and then plug in x equals a into that derivative. And that will give us m. This process is written out on this slide. So find the derivative according to the definition, the four-step process. Obtain the slope. So we'll look at a first example where the only thing the question is asking us to do is to find the slope of the tangent line and not the entire equation of a tangent line. So step one is find f prime of x. Step two is to say m is equal to f prime evaluated at 5 at the x-coordinate of the point of interest. Now this function, x squared plus 2x, if you go back to an earlier video, did we do that one? X squared plus 2x? Oh no, we did 3x squared plus 2. No, we didn't do it. Well, let's do it. Let's take the derivative. I need more space. Okay. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. F of x is x squared plus 2x. F of x plus h is x plus h all squared plus 2 times x plus h. So remember that, and I should have mentioned this in an earlier video, note that f of x plus h is not f of x end bracket h. You cannot do that. Don't do that. It's one of the most common mistakes at this point in the course. What that notation means is you are replacing all the x's in the expression with x plus h and then simplifying. So let's keep going with that. Let's FOIL. We'll get x plus h times x plus h plus 2x plus 2h, distributing the 2 into the bracket. Now we FOIL x squared plus xh and another xh, so 2xh plus h squared plus 2x plus 2h. There's no like terms, so nothing to combine. I'm going to take that expression. I know it's called the four-step process, and we can do some of the steps off to the side, but I'm just going to stop there for side calculations. I'm going to plug that in for f of x plus h. So this is equal to, might need more space, equals limit h approaches 0 of x squared plus 2xh plus h squared plus 2x plus 2h minus bracket x squared plus 2x, all divided by h. Now, if we do everything right, here's a little hint for you. If we do everything right, then all the pieces that don't contain h will cancel out at this step. So x squared, subtract x squared. 2x, subtract 2x. Every other piece that has survived in the numerator has at least one factor of h in it, one power of h. Okay, so now we have limit h approaches 0, 2xh plus h squared plus 2h all over h. If we try to evaluate the limit at this point, we have 0 over 0. So what we'll do is we'll common factor h from top. That's one of our tricks for 0 over 0's factoring, in this case common factoring. So h comes out, we get 2x plus h plus 2 all over h. Now we can cancel h top and bottom. Now we're left with limit h approaches 0 of 2x plus h plus 2. We can evaluate that. We get 2x plus 0 plus 2, which is equal to 2x plus 2. That describes the derivative of the function for any x coordinate. Step 2 is we want to find m. M equals f prime evaluated at 5, since we're looking for the slope of the tangent line at the point 5, 35, so we want to plug the x coordinate in. So that's going to be 2 times 5 plus 2, which is 12. That's our answer. What I'm going to do is I'm going to show you geometrically or graphically or visually or however way you want to put it. I'll show you what the interpretation of this is. So y equals x squared plus 2x, that's the function we're working with. We're looking at the tangent line at 5. So I'm going to zoom out enough that 5 is part of my graph. Okay, so 5 is not part of my graph. Then I'm going to put in the following line, y minus, I'm going to plug 5 into the original function to get the y value. So 25 plus 10, so 35, y minus 35 equals the slope that we just found, which was 12, times x minus 5. So what we just found is that black line. So I'll zoom out in a different way, hold on. My x-axis, I'll go from minus 10 to 10, just get a little better picture. And I'll hide that. Okay, so that's what we just found. We found a line that has a slope of 12. I'm going to zoom in to the coordinate at x equals 5. And I zoom in and I zoom in and zoom in and I zoom in close enough and you can't tell the difference between the function and this line. And that's what makes it a tangent line. That's a general feature of a tangent line. It approximates the curve at that point. It is the best linear approximation to the curve at that point. Okay, so I'll go back to the lesson. The equation of the tangent line is the quantity that I just computed to make that graph. We need an equation of a line. Y minus y1 is equal to m times x minus x1. Written on the slide as y minus b is equal to m times x minus a. That's the one you want to use. Don't use y equals mx plus b because it's more work. Be lazy. At least in this case, be lazy. Use the simpler one. Our process, in order to get all the ingredients we need for that line, we need to calculate the derivative of the function. We need to plug in the x-coordinate of interest. That'll give us our slope. And then to get b, or y1, to get the y-coordinate, we plug the x-coordinate back into the original function. So we're using the x-coordinate twice. Once being plugged into the original function to get the y-coordinate, and once being plugged into the derivative of the function to get m, the slope. So in this example, we're asked to find the equation of a tangent line to x squared plus 2x at x equals 1. And we already did the derivative. So I'm going to recycle it. We're going to be green. We already found f prime of x equals 2x plus 2. That's what we just went through that from prior example. So that was step 1. Step 2. M equals f prime evaluated at 1. So that's going to be 2 times 1 plus 2, which is 4. So that's our slope. Step 3, we have to get the y value from f of 1. That's 1 squared plus 2 times 1, which is 1 plus 2, which is 3. And I'll call this the y1 value. This is the y-coordinate corresponding to the x-coordinate of interest. And now we can finally put everything together. Y minus y1 is equal to m times x minus x1. So y minus 3 is equal to m, which is 4 times x minus 1. Let's see what the graph looks like and make sure that this is accurate at this point. Okay. So x squared plus 2x, that part's the same. Now we have y minus 3 equals 4 times x minus 1. And I'll zoom in at that point. Zooming in at 1, zooming in at 1. If we zoom in close enough, you can't distinguish between the line and the curve. The tangent line and the curve are completely overlapping, which is which again is the goal. And that equation of the tangent line is different at every x coordinate. That's why we had to update the graph when we moved from x equals 5 to x is equal to 1. All right. Aha, this is the one we already did in a previous video. Find the equation of a tangent line to f of x is equal to 4x plus 9 at x equals 0. So step 1, f prime of x equals limit h approaches 0 of f of x plus h minus f of x all over h. And then this was a diabolical calculation. We'll just go back and quote what it was. 2 over the square root of 4x plus 9. 2 over the square root of 4x plus 9 from prior slides. Okay, step 2. M equals f prime evaluated at 0, since that is our x-coordinate of interest. So that's going to be 2 over the square root of 0 plus 9. So 2 over 3. Square root of 9 is 3. Okay, step 3. Need the y value. We're going to get that by plugging our x-coordinate into the original function. So that'll be the square root of 0 plus 9, which is 3. Now we have all the ingredients we need to answer the question. Y minus y1 is equal to m times x minus x1. So y minus 3 is equal to m, which was 2/3 times x minus 0. Or you can drop the minus 0 since subtracting 0 doesn't do anything. Y minus 3 is equal to 2 over 3x. Or y is equal to 2 over 3x minus plus 3. adding 3 to both sides to write it in the form of y equals mx plus b. I'm going to circle the first one just to highlight the fact that that form of the equation of the line is the one that I'm expecting you to use. They're all correct, but if there's a multiple